Okay, more on quadratic equations. This lesson is on solutions of quadratic equations. This is probably pretty old news to you, but we've got a few new wrinkles that we're going to try here. Determine the nature of the solutions of a quadratic equation that has real number coefficients. I think this will be kind of old news for you. This is going to be new, though. Using sums and products of the solutions. We'll see what good that is for us. And then find a quadratic equation given its solutions. I think we did a little tiny bit of this in an earlier lesson. This next piece, and I want to point this out to you, anytime we have this 5 minutes piece, you can skip ahead if you want to. This is always a little review, a little prelude to what we're about to do. Probably not necessary. To solve number 1 using the quadratic formula, we see that it is already in standard form. I'm not going to get caught this time. These are in descending power order. X to the second power, x to the first power, and x to the 0 power. The leading coefficient is 3. The coefficient on my linear term is 7. And the constant is 2. We're going to start by figuring out what the discriminant is. B squared is 49. Everything was positive here, so I know when I multiply A and C times 4, it's going to be, this negative is going to stay negative. Okay, A times C, 6, times a negative 4, so subtracting 24. That's equal to 25. So we'll have x equals a negative 7, right? Our b is 7, and we always take the opposite sign. So we had a positive 7. We take the opposite sign. That's going to be negative 7 plus or minus the square root of 25. Oh, I'm not even going to bother writing the square root of 25. I'll just write 5. And that's divided by 2 times a, which is 6. Now let's look at the two possibilities here. One is that we've got negative 7 and a positive 5, so we'd have x is equal to negative 2 over 6, which would simplify to negative 1/3. The other possibility is x is equal to negative 7 minus another 5, which would give me a negative 12 divided by 6. So in that case, x would be equal to negative 2. So I have two solutions. What do I expect to have with a quadratic? That's right, two solutions, so that's good. Let's try this one. In this one, a is equal to 3, b is equal to 7, looks the same so far, and now c is equal to 5. We're going to start with our discriminant, which will be, let's look at it a minute, b squared minus 4ac. b squared is 49. A times c will be 15 times a negative 4, negative 60, and that is equal to what? What a lousy number, negative 11. So I've got x, I'm going to use the quadratic formula, is equal to, I'm going to use the opposite sign for whatever my b is. My b is positive, so it's going to be a negative 7 plus or minus the square root of negative 11 all over 2 times a, or 6. So the only real change we saw here was in the discriminant. And one thing is for sure, we don't have any real number solutions here, do we? But we do have a different kind of solution. We can take this negative 11, let's put it over here for a moment. The square root of negative 11 can be written as the square root of negative 1 times the square root of 11. True? And we have defined the square root of negative 1 as I. So that's what we're going to write. Plus or minus I, the square root of a positive 11, that looks much better, over 6. So we have two solutions again. They're not real number solutions. These are imaginary number solutions. Okay, we're ready to plow ahead with this new lesson. Didn't we already look at this? If b squared equals 4ac, how many solutions will the quadratic formula give? It'll only give one. Because this will turn out to be 0. You'd be plus or minus 0. You're only going to have one solution. And that's going to be negative b divided by 2a. What does the discriminant tell us about the solutions of x? Well, it tells us how many different solutions we're going to have. So how many? And I would say different, because even when we have one, in truth, those are redundant solutions. How many different solutions? What else does it tell us? Whether they are real or complex solutions. So we look at the discriminant, which is b squared, which in this case would be 16, minus 4ac. So a times c in this case would be 2 times a negative 4. There it is, 1 times 2 times a negative 4. What will that be? 8. We don't have to take this any further. We see that we have a positive number. When we have a positive number, we know as far as real square roots that we're going to have 2 real square roots. How about this one? How many real square roots will this one have? We've got 16. We take this and square it. Minus 4. And now we're multiplying a times c. So that'll be minus 16. And that will give us 1. Or if you want to think about it really carefully, it's actually 2, redundant. And real number, yes. Yes, they are real number. But they are redundant. Now how about this last one? Here we have, still b squared is 16, but my a is now 4 and my c is 2, so that gives me, what is that? 8 times a negative 4. Oh my goodness. Okay, so minus 32. So that's a negative number under the radical, this discriminant. So if I have a negative number under the radical, how many real square roots am I going to have? None. We didn't ask how many complex roots we would have. Two. That's right. Okay. Use a discriminant to determine the nature of the solutions. Okay. So we're going to square b, which is the coefficient on the linear. So that'd be 81. A times c is 8, and that's going to be times a negative 4. 8 times a negative 4 is a negative 32. We don't have to solve, right? All we're doing is figuring out the nature of the solutions. So these will be real, and we'll have two different real number solutions. Let's try this one. Wow, this is a biggie. We've got a negative 12, and we're going to square it. When we square a negative number, it turns positive, doesn't it? Negative times negative is positive. 144. Now we're going to multiply a times c, which gives us, in this case, 36 times a negative 4. Ooh. Let me try it. 36 times 4. Is it what I think it is? Yeah. 144. Which is going to be equal to 0. By the way, I should have just, up here, I should have just said it's positive. Okay, and this one's 0, so that means I'm going to have two of the same real number solutions, because we're a little more sophisticated now. We don't just say 1, because we know it's actually two redundant solutions. How about this one? We've got a b squared of 4, and then a times c will give us 30 times negative 4. 30 times negative 4. Oh my goodness. This is so negative, right? I guess it doesn't matter. It's either negative or it's not. This means we are going to have two complex number solutions. All right, that's pretty clear. For this equation, well, what have we got here? We've got the general form of a quadratic equation. The sum of the solutions is going to be equal to negative b over a. So if I've got x1, my first solution, well, how should I refer to the, oh, I see. Yeah, I'll be consistent with what I've got on my slide already. If I've got solution, I'm going to say sub 1, and I've got solution sub 2. So the sum of these two solutions, what would this look like? After I finish solving, I'd have x equals some number, we're going to call it s sub 1, and x equals some other number. Certainly with a quadratic we expect to have those two solutions. They might be identical to each other, but when we add them together, it's going to be equal to negative the linear coefficient divided by the leading coefficient. I don't know, that seems a little surprising to me. And we can use this to do some shortcuts. The product of the solutions, well, this was the sum. The product, of course, is multiplication. And that's going to be the constant divided by the leading coefficient. At least it's not got a negative in it. All right, let's how shall I do this? Just move this down a little bit at a time. I've kind of already done this. If I were going to be moving backwards, in other words, I've got the solutions and I want to find my factors. This works, doesn't it? I've got x minus the solution equals 0. These are our two mini equations. We're just going backwards now, from the solution to the mini equations to the factors, and when we multiply those together, isn't this interesting? Let me just get rid of this now. We get, you could work this all out for yourself if you like, but right here we can factor out an x, actually a negative x, and what we will have left is a positive solution 1 and a positive solution 2, which is exactly what we said we were going to find, that the sum of solutions was going to be negative b over a, and the product of solutions, which is right here, is going to be c over a. So the whole purpose of this is just to give you little shortcuts for solving some of these problems. Find without solving. Well, I understand. I just use the word solving for doing this. Well, without going through the full zero product property thing, you can actually find the sum and the product of the solutions. The sum, what is the sum equal to? What do we say? The sum of solutions is negative whatever your b is over whatever your a is. So what's our b in this case? It's actually a negative 3, and our a is 4. Without solving, we can say the sum of solutions is 3/4. So that's the sum. And the product of this is going to be c over a without any change in sign. C is 2, a is 4. So my product of solutions is 1/2. Part 2. Find a quadratic equation for which the sum of the solutions is -2. Okay, so if I've got -2, and I know that that's equal to negative b over a, and the product is 6, and I know that that's equal to a positive c over a, and here I've got the equation right here. This couldn't be simpler. I'm just going to plug those in. This actually isn't even all that much fun. It's only fun if it's challenging. So it's going to be minus my negative b over a, which is a -2, and the x, I don't want to forget that, plus c over a, which we know is 6. That's equal to 0. I should simplify this. X squared plus 2x plus 6 equals 0. So if you want to talk about the sum of the solutions and the product of the solutions, you can do a few shortcuts in getting some answers without having to go through the full solution process. Oh, this is more like it. No, this I really like. Find a quadratic equation whose solutions are 5 and 7. Okay. So the sum of solutions is equal to negative b over a. And what is the sum of the solutions? It's a positive 12. The product of the solutions is equal to c over a. And we know what that would be. If we multiply these two together, we get 35. So how about I just pop those in? So I've got x squared minus my negative b over a turned out to be 12 x. I'm so tempted to forget this. I hope you don't make that mistake. Plus c over a, which is 35, equals 0. So the quadratic equation whose solutions are 5 and 7 is x squared minus 12x plus 35 equals 0. Now you see that this is actually rather powerful. If you know this, you can figure out that equation fairly quickly, a lot quicker than the other approach that we have used. Let me see. I want to clear this away. This is just showing how that works, and let's hope that the answer I got earlier is the same answer. Yes, it is. I should probably always check that, and that way if I've made some stupid mistake along the way, I'll find it. Well, let's try it again. Find the quadratic equation whose solutions are this. So we want to find out what, maybe I'll change my pen color here. We're going to go for the sum, and that'll be equal to negative b over a. Well, what is the sum of these two things? Yikes! We have to get a common denominator, right? I'm going to do it up here. 2 over 3 plus 1 over 5. What would our common denominator be so that we can add these two fractions? Yes, 15. And to get this to be 15, I'm going to multiply it by a fancy 1, 5 over 5, and this by a fancy 1, 3 over 3. That's going to give me 15 in my denominator, and in my numerator I'm going to have 10 plus 3, 13. So negative b over a is 13/15. And c over a, I know that's the product of my solutions. If I multiply these two together, I get 2 over 15. Let's put it into the equation. We've got x squared minus what we have for a negative b over a, which is 13 over 15. And I'm remembering now that I need to put that x in, plus 2 over 15 equals 0. Now if I'm going to put this into standard form, I should get rid of these fractions. How can I do that? Clearing the fractions. As long as I do the same thing to both sides of this equation, I'll be okay. I'm going to multiply this whole thing by 15. When I do, I get 15 x squared minus 13, whoops, let's get that 1 in there, 13x plus 2 equals 0. Well, let's check my answers and see. Oh, thank goodness it matches. And this is just showing you how that whole thing works. But isn't it nice to have this little shortcut? Saved us from having to do all of this. I will see you in class.